Today we're going to expand on numeric and algebraic expressions and explain why variables are useful and how they're used in algebra. We're going to see why variables are needed in order to solve math problems, and by the end of the lesson you should be able to understand why we use algebra and why variables are an essential part of algebra. Alright, so here's a little quick warm-up. Write the following as an algebraic expression. The sum of, remember sum means plus, of 10 on one side, and when we see the n we go to the other side, 3 times the number m. So 3 times the number m. That's our algebraic expression. Alright, so here's an example of a word problem. So here we have the table below shows how the height above the floor of a house of cards depends on the number of levels. So here what it's saying is that the height of the table, no matter how high you're building off of it, is 24 inches. So you're always going to have 24 inches. All right, and then you're going to need to add to that how many sets of cards, how many rows you're going up. So the rows is your unknown. We're going to just call that n. And how many rows, which is n, and each row is 3.5 inches high. So this is going to be our algebraic expression. And this little chart helps because it kind of shows you how it goes up and what changes, so that when you plug in a row in here, or how many levels you're building up rather, your answer is going to vary. And that's why variables come in handy for things that may vary depending on how much you use. Another example would be if you're clothes shopping and you need to buy so many shirts, if there's a discount after so many shirts, things like that. So in this example here we are using height and levels of cards, and you will see other examples, and you can see down here that this matches what they tell us. But as you break down the problem, what is the rule for the height? All right, like I said, the height of the table, and then this is the height of the card, and then n is the number of levels. And this is a pretty basic equation in word problem from what we're going to see. Let's take a look at another one. So here, how does it apply? So this is a problem you will see later. You may see it in algebra, you'll definitely see it in geometry. It relates to the number of sides on a particular shape. So this one here in particular is talking about how many triangles are formed within a shape with an unknown number of sides. So here we have a 6-sided polygon, which is also known as a hexagon. And what the direction tells us is that if we have a square and we draw a line from one vertex across, if we pick one of the corners and draw it to each side that isn't already touching, we are going to form 2 triangles. And notice we're always subtracting 2, because if we have a pentagon and we pick a vertex and draw it to the non-touching sides, we can see I have made 3 triangles. So 5 minus 2 gives us those 3 triangles, and so forth. So when we're trying to make this equation, This is the number that's changing, the number of sides, so that's going to be our n. The other number is what's staying constant, so we're just going to rewrite that. So our equation for the number of triangles that are inside a polygon, if you're just drawing from one vertice, so non-overlapping triangles is what it says in the problem, is always n minus 2. So if we were looking at a 10-sided polygon, then the number of triangles would be 10 minus 2, which equals 8. So remember, a variable is used in place of a value because either the value is unknown, or you are trying to find it, or in the case of these word problems, it represents something that could be changing. So variables can be very useful, and this is just getting our feet wet, getting used to these variables.